Welcome to This Explainer. Today we're looking at a truly fascinating story. It's all about how humanity took the sheer, untamed chaos of the physical universe and actually brought some order to it. How? Through the power of measurement standards. We're going to be diving into the fundamentals of physical quantities and the SI system. So let's just jump right in.
I want you to imagine the number 10. Just 10. Now, if I walked right up to you and simply said 10, what would that even mean to you? 10 what exactly? $10, 10 minutes, 10 apples? By itself, that raw number is completely meaningless. It has absolutely no context, no anchor in the real world. And in the realm of physics and science, a raw number like that is pretty much useless to us.
And honestly, that perfectly illustrates the need for our hero here, the unit. Basically, a unit is a fixed, standard quantity that we use to measure and express physical quantities. It's the whole concept that actually gives a number like 10 its purpose. The second we add a unit, that 10 transforms into 10 meters, or say 10 kilograms. Suddenly, bam, we have a clear, undeniable meaning. This one simple addition literally forms the entire foundation of how we measure the universe.
So, here's our roadmap for today. First, the meaning of measurement. Second, the 7 fundamental units. Third, building blocks, derived quantities. Fourth, mastering scale and dimensions. And fifth, avoiding common measurement mistakes. All right, let's hit section 1, the meaning of measurement.
For an incredibly long time, different parts of the world just measured things differently. And as you can probably imagine, that caused absolute chaos for trade, for science, for pretty much everything. So the turning point was really in 1960. Science desperately needed a universal language. That's when the Système International des Unités, or the SI system, was developed, and it's managed by the International Bureau of Weights and Measures, the BIPM. Now, what makes the SI system so incredibly powerful is its universal acceptance. Plus, it has this beautifully consistent decimal-based structure. Basically, the whole shebang operates on powers of 10, which makes global scientific inversions wonderfully simple.
Moving right along to Section 2, the 7 fundamental units.
So, if you look closely, all physical quantities divide into 2 main categories, fundamental and derived. I like to think of it kind of like a giant box of Lego bricks. Your fundamental quantities are those individual core Lego blocks. They are totally independent and absolutely cannot be derived from anything else. The derived quantities, on the other hand, well, those are the complex structures you build by snapping those fundamental blocks together. You literally cannot have the derived quantities without first having those fundamental ones. And here they are, the magnificent 7. These are the 7 independent base quantities that form the rock-solid foundation of all physics measurement. We've got length, measured in meters, mass, in kilograms, time, in seconds, electric current, measured in amperes, temperature, in Kelvin, the amount of substance, in moles, and lastly, luminous intensity, measured in candelas. Every single physical measurement you can possibly think of in the known universe is ultimately built right on top of these 7 fundamental pillars.
Okay, section 3, building blocks, derived quantities.
Let's actually see how our fundamental Lego bricks snap together in real time. Take a look at Newton's second law, force equals mass times acceleration. Notice how this formula breaks down. We know the fundamental unit for mass is the kilogram. Acceleration is a bit more complex. It's meters per second squared. When we multiply those together, we get a derived unit, the kilogram meter per second squared. Now let's be real, saying that every single time would be a total mouthful, right? So we give this specific, snapped-together combination a brand new name, the Newton. I think this beautifully illustrates how complex concepts are really just basic units working together in harmony. And the Newton is really just the beginning. By snapping together different base units and different formulas, we get the entire everyday language of science and engineering. Energy? That's measured in joules. The power of your light bulb is measured in watts. Pressure is captured in pascals. When we're talking about electrical charge, we use coulombs, and the potential difference pushing that charge, well, that's measured in volts. Even the frequency of a sound wave or your favorite radio broadcast is measured in a derived unit called hertz. All of these, every single one, are just those magnificent 7 base units mixed into different combinations.
Which brings us to Section 4, mastering scale and dimensions.
Now, this is where the immense power of the base 10 SI system truly shines. Instead of inventing entirely new, confusing words for massive or microscopic measurements, we just attach prefixes to our base units. It's so simple. Notice that if you want to scale up, you just use prefixes like kilo for 1,000, mega for 1,000,000, or giga for 1,000,000,000. And if you're measuring something microscopic, you just scale down. You use milli for 1,000th, micro for 1,000,000th, or nano for 1,000,000,000th. So a kilometer is instantly recognizable as 1,000 meters, right? And a millimeter is exactly 1,000th of a meter. It's just an incredibly elegant, logical way to adapt our fundamental units.
But alongside scale, we also have something called a dimensional formula. Think of this as the unique DNA fingerprint of any physical quantity. It's basically a way of writing out a quantity entirely in terms of the powers of its base quantities. For example, force has the dimensional formula mLt to the power of -2. That represents mass, length, and time. Writing out these dimensional formulas ensures we actually understand the underlying mechanics of what we're measuring. It strips away all the names like Newton or Joule and just shows us the bare structural code underneath. It's really cool.
All right, let's move into our final section, Section 5, avoiding common measurement mistakes.
So a really crucial distinction to keep in mind is the difference between the modern SI system we've been discussing and an older system called the CGS system. CGS stands for centimeter, gram, second, whereas our modern SI system relies on the meter, kilogram, and second. Mixing these two up, that is a classic mistake. If you calculate force using the CGS system, your answer is going to be in dynes, but in the SI system, your answer is in newtons. You absolutely must stick strictly to one system, and preferably the SI system, or your calculations will just completely fall apart.
And honestly, mixing up these concepts leads to confusion every single day. A perfect example is the difference between mass and weight. When we step on a bathroom scale, we usually say something like, oh, I weigh 70 kilograms. But structurally, as we've just learned, the kilogram is the fundamental unit for mass, which is just the amount of matter in your body. Your actual weight is the force that gravity exerts on that mass, which technically means your weight should be measured in the derived unit of newtons. Other really common pitfalls include just forgetting to convert units before plugging them into a formula, mixing up those CGS and SI systems we just talked about, or writing out the wrong dimensional formulas. Attention to detail here is literally everything.
Which brings us to a final thought for you to chew on. What would our modern world of global medicine, international space stations, and instant internet even look like without a unified language of measurement? Think about it. If a doctor in one country prescribes a milligram of medicine, a pharmacy in another country knows exactly what that means. When engineers from a dozen different nations build pieces for the International Space Station, they all fit together flawlessly out in space, because they are speaking the exact same structural language. Without this standardized foundation of SI units, global scientific cooperation would just instantly collapse into chaos. And really, that is the true quiet power of the unit. Thanks for learning with me today. I really hope this explainer gave you a brand new perspective on the invisible framework that holds our entire modern world together.